Okay, so now that we have our prototype working, or at least it seems to, how do we get him into the rig? Well, I could just obviously, for example, save this scene and then merge it into my rig file, but that's going to be kind of not really great. So what we're going to do is instead we're going to create an assembly that we can reuse in as many rigs as we want. What's an assembly? An assembly is basically sort of, you can think of it as a self-contained entity that has inside a bunch of stuff that you can reuse in many projects. The things that you can have inside of an assembly could be just like, for example, some nodes that do some math and generate a result, and you want to reuse that lots of times. You can save that as an assembly. It could be a bunch of objects that you want to bring into different scenes. Those could be assemblies too. In this case, we're going to create one that is a combination of all that. We're going to create an assembly that is these guys, and that way we're going to be able to reuse this setup in any part of a rig, or as many times as we want, or also in other rigs. So let's see how we can develop assemblies in Modo. The first thing I'm going to do is I'm going to rename all my stuff here. So let's call this guy rig rotator, and this guy is going to be rig tracker, because this guy keeps track of where the rotations are going. And then this guy is going to be rig marker west, and this guy is going to be rig marker south, and this guy is going to be rig marker east, and rig marker north. And we can actually order these a little bit so that they make sense from the going clockwise, for example. That's the way I tend to read these things. And the other thing we're going to do is we're going to create a group locator, and we're going to call this guy assembly direction reader. And let's take all that and move it in. And we'll get a warning. Yeah, our rotator object cannot be reparented because it has animation on it, and Modo doesn't like that too much. So let's delete the animation, select all the channels, and say remove all. And now there's no animation on them, and now I can drag and drop it in. Let's see what we have. Okay, there it is, our rotator, our tracker, and our markers, and our little group locator, everything starting at the origin. So how do we create an assembly that is going to contain all these guys and the related nodes to get this setup to work? Well, there's several ways of creating them. I'm going to show you the one I prefer the most, especially for this kind of tool development that you can do in Modo. And I'm going to create them directly here in the schematic. There's two types of assemblies you can create. Well, they're not necessarily two types, it's just where they are located. One is a root level assembly, and the other one is a sub-assembly. The root level assembly will create it outside of this workspace, and I'm going to show you. If I go to the top level, here it's where it would be created. And the funny thing is, workspaces in the schematic view are basically that. They're a special kind of assembly. It's an assembly called a workspace. So this assembly, you double click on it, and it has nodes that you can play with inside of that particular workspace, and they are part of the scene. But you could just as well create here an assembly node and then work inside of it. Now in my case, I'm going to create a sub-assembly, which means that the assembly is going to be a child of the current workspace. And the reason I'm creating it over here is because I want to be able to take all these nodes and move them over to this assembly. So let's give it a name. I'm going to call it my tools direction reader. Okay, and you will see this little node here with a gear appear, and that's your assembly. You might actually see like a little gear icon on it. I usually turn those off here in the display group assembly previews because they don't really display anything. So it's just a waste of space. So I have them turned off. Now, if you double click on the assembly at this point, you will get this. You will get just an empty workspace and two nodes, one called assembly inputs and assembly outputs. I'm going to show you what these guys do in a second. And then we have a drag and drop items or channels into assembly, little sign, so you can know you can drag and drop stuff into this to make it become part of the assembly. So let's go back up and let's take all of our nodes, select them, and then right click on them and say move nodes to assembly direction reader. So everything is going to disappear, and now everything is in here. If I double click, you'll find them right there. Okay, so here they are. Now they are part of the assembly. Let's start to get this to work better. So we're gonna say, okay, let's move this like so. I'm gonna just lay out my stuff over here. This guy, this is my rig tracker. This is the west marker and it's math. I'm gonna just lay down these guys so I can better understand what's going on. So we have north over here, then we have east. Let's get them closer together. Then we have south, and we have west. Okay. All right. So there's several things we're going to do with this assembly. We cannot really just move it onto our projects like this because it lacks a little bit of functionality. And also there is one problem that I have not shown you yet, because the intention was to first get the prototype to work and then to actually reuse this in the rig. But there's one thing that we need to do to get this to be as usable as we need it. And I'm going to show you what it is in a second. Let's take a look first at the inputs. If I come out of the assembly and I select it, you can go to properties. And right now there is no properties for this particular assembly because there are no channels exposed. But in assemblies that do, you would see here a tab that says assembly channels or properties. I don't remember. But let's create some. Let's say, for example, that I want to be able to control the size of the assembly just using one little spinner. So what we would do is let's create a new input, and you do that. Maybe I didn't do it clearly by hitting on the plus sign. So you get a create user channel dialog, and let's call this one size. Okay, and the username is the name that you will see in the UI of the assembly, and the channel name is the one that is internally used by Modo to reference the channel you're creating. And then you have to select the type. So my size, it is going to be a float scalar, and the default value. Oops. let's change that. I accidentally hit enter and I was not done entering all the values that I needed to enter. So if that happens to you, the way to edit a channel that you've already created as an input on an assembly is to right click on it and say edit user channel. So there we go. Unfortunately, I don't have access to this right now, to the default value, minimum value, and maximum value. If you select to edit the channel value, then you just basically enter a value there. You can also I can't change the or you can rename it right there. There was a way to also change the data type used by the channel, but in this case I'm just gonna remove it. Looks like it's not letting me just choose that channel, so let's remove it here in the channel list. Remove. Where's the delete channel? There it is. It was down there. Let's create it again. size, default value, the default value is going to be, let's say 1. And then the minimum is going to be 0.1. And the reason why I'm doing this is because I don't want the user to be able to set this to 0. I want to have like a minimal display on my assembly and no maximum. Let's just say OK. Yes, that happens sometimes when the channel name is not provided. Let's call it the same. OK, now we have our size channel. So this channel, the purpose of the inputs, if I go back to my properties panel, now we have this assembly channels tab, is that you have right here a channel on the UI of your assembly that you can set a value to. And that way, you could wire a lot of things inside of the assembly that depend on this single value and drive everything from here. That's the whole purpose of using assemblies, basically. So let's, for example, start driving this guy's display size, which is 500 millimeters. I'm going to select that channel, right click, and say add channel to schematic. You don't see it, it's off screen, but it's there. So immediately brings the node in here. And because it wasn't part of the schematic, so, and then we have our radius. If I wired this directly, let's see what happens to this value. It becomes 1 meter. So basically this is twice as big as I would actually like it. So I need to do a little bit of math here. So I'm going to click on the connection. I'm going to say add channel math multiply. And that inserts this new node in between these two nodes because the connection was selected when I created the node. And I'm going to set the B value to 0.5. So that multiplies the incoming size value by 0.5, which basically is the same as dividing by 2. And that's the radius of my little rotator there. So if I go back out to my assembly and I start playing around with this, you'll see that it drives the size of our rotator locator. And we can do the same for these other guys. So let's select those. Let's go to display. And in this case, because they're normal locators, it's the size channel. So let's add that to the schematic. They all get it. And let's see what values we get. It's a size of 1 right now. And it correlates perfectly. So I'm just going to wire this into all of their sizes. And we need to do it for our friend here too, the tracker. And I'm going to use basically the same value that I've been using for the rotator. And because it's floats, I just need to wire it into the 3 channels separately. There we go. So now I can pretty much resize my entire assembly from this channel, which is great. The other thing I would like to do is to not only resize the locators, but also to resize or affect the distance between them and the center of the assembly. So that's also quite easy to do. Let's see what we have. If I select this guy, I see he is 2 meters away on X from the center of the assembly. So I can just take this channel and add it to the schematic, and I'm going to do the same with all of these guys. Where appropriate, you have to check what channel is the one you need to add. Let's add this one. And let's add this one. There you go. All right. So that's great. Now, as you can see, they're 2 meters apart. So that means I need to take this value and multiply it by 2. So let's add a math multiply node. And it's going to take this value and multiply it by 2. Okay. And that's going to give me the distance that I need for this node right here and this node right there. Now, it's not going to be the same I'm going to use for these two, because if not, these guys are going to move into the, these two guys are going to move on top of the other two, because those are in the positive side of the grid, and these guys are in the negative side. So I need another node, another multiply, that is going to take this value that I've already multiplied by 2 and multiply it by -1. So that these guys stay on the negative side. So this guy negative y and this guy negative x. Okay? So good so far. Let's move these guys up here. Just wanna. All right. So let's see what happens if we go back up and we resize our assembly. Yeah, it's great. We only missed one, dude. Our little arrow here. Let's take care of that one very quickly. So this guy, it's this channel, and it's positive. So we just need to take him and wire it in there. And that's it. We are done. Well, we are done with this part of our assembly. Now, there is one thing that I would definitely want to do, and it's check how this works on something that sort of resembles an arm. Okay, so I'm gonna create, let's say, a joint chain. Let me go back to here. Okay, there you go. A very quick one. And let's take this guy, rotate it a little bit like that. Okay. Now, before I continue placing this guy over here, we have to do one thing. Our assembly is working, but it's not going to give us any results of any kind because, well, we're not getting the values out. They're still here in these nodes. The dot product nodes, so we need to do something about these guys, and we need to put those values out as outputs so that we can read them. So let's create a few outputs for our assembly, and the username of this one is going to be north value. If you hit tab, Modo will autocomplete the channel name. And the type, it's going to be a vector. Angle. Oh, did I load distance, angle, light, time, speed, force, mass? Oh, sorry. The type is float. The mode is vector. Yeah, I forgot about that. We're using float values, but the mode is a vector, and it's going to be an XYZ vector. Okay, because we're going to be dealing with directions. Let's leave the default at 0, no minimum, no maximum. Okay. Now we need a east value, south value, and west value. Okay, now we have our 4 outputs. Now I'm just going to wire these dot products into each output. Okay, let's do north, let's do east, let's do south, and let's do west. So now we have one input channel, a bunch of stuff that happens in here, including the objects that are part of the assembly, and an output, a series of output channels. My assembly is almost complete in terms of something that I can reuse in different scenes. There's only one thing I need to do. When you create assemblies in Modo, and if you intend to reuse them in other scenes, to make them truly portable, you must make sure that all of the objects and nodes that are part of the assembly or used by the assembly are inside of it. So in this case, that's important because I'm missing one piece, and that is my group locator. If I don't include the group locator in here, when I merge the assembly into a different scene, all this is going to be spilled over the scene with no hierarchy in it. So I need to include my group locator. So let's add the group locator right there. And we don't need to do anything to it. We're just going to leave it there. And that's about it. The whole purpose is that he gets saved with the assembly. Okay, if we go back up, let's see what happens. Oh, look. Our assembly node looks completely different. Now we have one input channel that actually has an input, so it can be driven by something else and pass those values into the assembly, and a series of output vectors that I can just plug onto something else. And you have the components for the vectors. So that's great. You also have them here in the UI of the assembly in the properties panel. Okay, so that's looking good. Let's see if we can test our assembly so that it does something. So I'm going to take my direction reader and I'm going to drag and drop it with match, set as a drop action onto this joint. So as you can see, everything lines up. And let's create a little animation on this guy too. Well, just test our assembly. Let's say we're going to rotate him on the x-axis. Let's say this is his rest pose. Let's zero everything. X. And let's rotate him up. Okay. And let's rotate him back down. Okay. So we need a way to drive the animation of the objects inside of the assembly using an external object. Let's go inside again. So what do we need? We need the rotator to follow the rotations of that particular joint, right? So there is a very easy way of doing that, actually. I am going to take this guy, go to the channel list, and expose its world rotation channel. Okay? So now that it's exposed, I can select this channel, right-click on it, and say Expose Channel as Input. This is going to create an input on the assembly with the proper data type for the channel I have selected and wire them together. It's actually a very fast way of just creating inputs on the assembly. So when I do that, you can see that we get exactly that. We have a world rotation channel wired to this guy. Okay. Of course, that when you see the assembly from the outside saying world rotation, I'm not sure what that means for the user, of course. So we can rename that. Let's right click and say rename exposed channel, and we're going to call that input rotation matrix, so that the user knows he's dealing with a matrix. And actually we're going to be very explicit about it. World matrix, or input world rotation, or whatever you want to call it. The whole idea is that it becomes really clear what this is going to be used for. Now I can take this joint, let's add them here in the schematic, and again take its world rotation channel, okay, and expose it, and let's link them together and see what happens. Our tracker is tracking because the rotator is rotating. So everything seems to be working just fine. Now, are we getting anything usable out of our assembly? Let's check the channels that we have. Well, I don't know if we can distinguish them here, but let's go to the channel list. These values that we're getting look nothing like something I could use. I mean, before here, when we were in the neutral pose, everything should be zeroed out, and now it's not the case. What happened? Well, something very interesting happened, and this is a new problem that we have to solve for our particular assembly. Before, our prototype worked perfectly because we worked from 0, 0, 0 at the origin. Well, I mean, we worked at the origin at 0, 0, 0. And everything was oriented in world space with no rotations and everything. So our dot product results were starting at 0 and giving us some very nice values. But now we move the assembly somewhere else in space. Okay, it's like over here, and its neutral pose is not neutral anymore. It's rotated like so. So that's why we're getting these really bizarre values. So what we need to do is find a way of sort of fooling the assembly into thinking at all times that she is at 0, 0, 0 facing world orientation. So we're trying to sort of move the entire world around it, so she thinks she's properly oriented and we have correct values coming out of this. How are we going to do that? Well, we need a new point of reference, and that point of reference needs to be the place at which the assembly is going to be located. So I could think of a couple of ways of determining where that point is. The easiest one would be just to take the assembly group locator, because we're matching that onto the location that we're going to be tracking from and reading that. So how about we do exactly that? Let's take our group locator and let's take its world position, okay, channel. There we go. What are we going to do with it? Well, if you know a little bit of vector math, you will know that it's really easy to return this to the origin, actually. We just need to take the distance of each one of these elements from the center, which is the assembly, the direction reader, and subtract from that the vector that is the world location of where the assembly is right now, which is this channel that we just exposed. So we're going to do a few vector subtractions to get the correct location for our purposes. So let's do that. The first thing I need to do is to do a vector subtraction. I need vectors, and right now I'm dealing with matrices. So let's convert this matrix onto a vector. Let's create a matrix node, matrix vector. Okay, this will allow us to convert a matrix onto a vector. We need to set the row, the matrix row, to translation, so we get the entire translation part of the matrix, and we just wire those together. Okay, so now that we have that, you will see here world coordinates for the location of our group locator. So we need 4 more for these guys over here. So I'm gonna duplicate that and just disconnect it. Okay. Oh, actually, I don't need them. I already have them here. So forget about that. So now what we need to do is not feed into the dot product nodes the original vectors, the original position vectors of the objects, because they are in world space. We need to feed this the resulting subtraction operations so that we get actually the correct references. So in this case, I am not going to reference this tracker. Well, this is my tracker actually. Yes, I need that here. But we're going to subtract all these guys, these vectors, from this guy over here. Okay? So to get the relative position of this tracker onto its parent, not in world space, which is what I'm getting right now, I need to subtract this vector from it. Okay? So let's leave this guy here, and let's add a vector subtract node. So what I'm going to do is take this output, my vector A, and subtract from it my vector B, which is, let's call it origin. Let's rename this matrix vector. We'll calling him origin. Okay. So now I need to take all these connections with and move them over to this new output. There we go. Okay, and now we need to do the same thing for all these markers. So I need to take these vectors and subtract from them the origin that we're using now. Okay, so let's add another subtract node, and we're going to duplicate that 3 more times. Okay, and we're going to take each one of these. It's going to be vector A. Okay, and we can shift select vector B on each one of those, and with shift enabled, just send those wires over to our origin vector, and we have the subtractions. And now we just need to wire them where they need to go, which is in the vector A input of each one of the dot product nodes. Okay. So let's see what all this is looking like. Let's select our outputs. Well, look at that. Everything is zeroed. And as I play back the animation, you can see that only the proper axis is giving me values here that I need to read. So if I go like this, and let's take the joint directly and rotate it myself. Yeah. Look. Everything's looking good. So that's great. Looks like we solved that problem for our assembly. The only thing that is left is, well, how do I get to use all this in my rig? Well, that's actually very simple. You just have to go up here and select your assembly, right click, and say Save Assembly. So what this is going to do is it's going to give you a dialog so you can save your assembly to disk somewhere. And if it's part of your assets assemblies folder for your Modo content, it's going to show up in your presets browser. And actually, as you can see, I have this category over here that I've created in my assemblies folder that holds a bunch of assemblies that I have created myself to help me with lots of rigging problems that I encounter. So I've created reusable setups for all of them, and I can just bring them into my setups whenever I need one. So the way to do that, if you're curious, once you've saved your assembly and you can find it in the preset browser, if you want to reuse it as part of the scene, all I need to do is to select it, and well, this is the way I do it. I just right click on it and drag it over to the schematic, and it gets instantiated in the scene. As you can see, it's part of the scene right there. These are the objects contained in the assembly, so I can go inside and I can see what's in there, what the assembly is doing. If you want, you don't necessarily have to. And if you go to the items list, I can see that there's the elements of this particular assembly that I have. So that's it. That's how you would go about creating your own assemblies in Modo, and how to reuse them. So this is the end of this video. I hope that this helps you realize how powerful Modo can be when it comes to development of certain tools for whatever purpose. I mean, since the schematic is used not only for rigging but also for particle systems and dynamics, I think you get the picture of how far you can start to take this. So that's it. I hope you liked it. Actually, as you've seen, I use this functionality a lot to create stuff that I need. And the next video, we're gonna bring in this assembly and start doing stuff with it in in the actual rig for the character. So see you there.